In this example, we examine the function y equals 2 to the minus x power. Okay, now this is a convenient way to write this function, but another way to write this function is 1 over 2 to the x, which is the same thing as 1/2 to the x power. So here, this is the base. A lot of times they use the letter A for the base. So the base here is 1/2. So in general, like every single time, the base should be positive. However, you have two different situations. One when the base is greater than 1, and one where it's still positive but less than 1. So here we have the base here, 1/2 is less than 1. On the other hand, another way to look at this is just make your base always greater than 1, but then you could have either a negative x or a negative number times x or a positive number times x. And we'll see that that's going to make, let's see what that does here. Okay, so let's put in some numbers. So 2 to the minus 1 is 1/2. 2 to the minus 2 is 1 over 2 squared, which is 1/4. Okay, so what we see is that as x increases by 1, y is halved each time. Then if you go the other way, as you decrease x, then y doubles. So for 0, we get 2 to the 0, which is 1. 2 to the 1 is 2. 2 squared is 4. 2 cubed is 8. Okay, sort of got carried away there, but let's see how that goes. So, I mean, okay, what we see is that the exponential function gets small very quickly as you increase. So this is exponential decay. That's what this is called. All right, and so when would you have exponential decay? So the applications are radioactive exponential decay. All right, so actually, is that the right word? But okay, so the idea is that you have some substance that that is emitting radiation, and it's an element, and the element starts as one element and it changes to an element, or it could start as an isotope of one element and then transform to another element, and there's a half-life, so it's over a certain increment of time. You get half of it decays into something else. So that would mean that, say, you start off with 1 kilogram of carbon-14, and then after a certain amount of time, which is like 5,730 years, that carbon-14, and carbon-14 is an isotope of carbon. So you start off with a kilogram. After more than 5,000 years, around 6,000 years, you get half of that, then half of that, and half of that. I think a kilogram's a lot. I don't think you really see a kilogram lying around. But anyway, whatever amount that you have, every increment of time, half of that decays. So you start off 1, a half. All right, so this is the graph of that. So that's an application. The domain is R. The range is all y, such that y is greater than 0. It's decreasing, and let's see, as x goes to infinity, we see the y goes to 0. As x goes to negative infinity, which means x is going to the left, we see the y goes to infinity. And this has a horizontal asymptote. The x-axis. And by the way, one way to look at this graph here for y equals 2 to the minus x is that it's a reflection of y equals 2 to the x. So it's a fact that if you have a function and you look at the graph of the function, and if you replace x by negative x, it reflects around the y-axis. So replacing x by negative x reflects around the y-axis, and that's an easy way to think of what y equals 2 to the minus x looks like.